Let's begin refactoring our application so that it can support a web app interface and not just a JSON API. I've gone ahead and opened up the server.js file inside of the lib directory. I'm going to scroll all the way down to where we have defined this router. The paths on this router were fine for a JSON API. We didn't need any prefixes to any of these services because we didn't have anything else going on in this application. Now that's starting to change, and we actually are going to want to move a lot of these services up into their own API directory or their own API prefix just to get out of the way of any other new user-facing routes that we will need for the web app. So I'm going to modify these three services, users, tokens, and checks, so that they exist off of an API prefix. So rather than making a request to localhost/users, a client would now make a request to localhost/API/users, for example. I'm going to leave ping as its own path because that might be useful, and it's not really part of our API, it's just the app itself telling anyone who might ping it that it is alive. While we're here, in anticipation of the routes we're going to build, we might as well fill out this router with everything that's going to need to be there in the coming lectures. So at the top, we're going to add a path of a nature we haven't seen before, and that is an empty string. And that empty string will route to a handler called handlers.index, which of course doesn't exist yet. If you look at this, you can probably guess what this means. Until now, any path that a user might hit has had a string of a length. It's always had something in it. But now, like any normal web app, we're going to have users who request the base directory, who request no path at all. And that will mean that we need to serve them the index file of this new website. So for them, we are going to say that if you request no path, you should be served by the index handler. Now let's build out a few of the other ones. Before a user can do anything, the user first needs to exist. And so the first route that we want besides the index is account/create. This is the path in the browser that the user will actually visit if they visit, localhost 3000 or whatever the base directory is where this app is hosted, and then they click on sign up. They'll be taken to the domain.com/account/create. And this handler called handlers.accountCreate will need to serve them an HTML page showing them a sign up form where they can fill out information and sign up for an account. Once they're inside of their account, they're going to need to be able to edit their settings. So I'm going to create a path called account/edit that will route to a handler called handlers.accountEdit. Once their account exists, they also need the ability to delete it. And that is going to be a button that exists on the account edit page. But once they have deleted their account, they need to be taken to a your account has been deleted page. And so we're going to set up that route at account/deleted. That'll be served by a handler called handlers.accountDeleted. In order to do anything on the edit path or in order to reach the deleted path, they will have needed to sign in, or in our parlance, they need to create a session. And so we're going to create a route called session/create. If they visit the home page and then they click a button that says sign in, they'll be taken to a login form. And that login form is going to be served at the URL/session/create. And it's going to be served by a handler called handlers.sessionCreate. Similarly, they need to be able to log out, which is deleting a session. And after a session is deleted, they need to be taken to a page that says you have deleted your session, or in user speak, you have logged out. So we're going to create a route called session/deleted that they'll be taken to after logging out. And that'll be served by handlers.sessionDeleted. When they're signed in and they want to create checks, the first thing they're going to need to see is a dashboard of their existing checks where they can click on them and reach more details, or click a button to be taken to a page where they can create a new check. This dashboard page is going to be called checks/all, and this, like many of these other routes, is going to be a protected route that you can only reach if you're signed in. Checks/all is going to be served by handlers.checksList. As I mentioned, they're also going to want to be able to create a check on a special page that gives them a form that they can fill out in order to create a check, and that path that they're on when they're doing that will be checks/create. That'll be served by a handler called handlers.checksCreate. They're also going to want to be able to edit and delete a check. If they delete a check, they'll simply be taken back to a checks list page. But if they edit it, they will simply need to see a message on that same editing page saying that their changes have been saved. That page is going to be called checks/edit. Checks/edit will be served by handlers.checksEdit. That's all the new routes that we need. And now we can actually go about modifying the server a little bit more so that it can support HTML content types. Right now it serves JSON and it only serves JSON, so we're going to need to modify that behavior. So we're going to go up inside of the unified server function and look for where we are passing the incoming request to the chosen handler. To review, we expect all handlers to call back two optional fields: a status code, which will default to 200 if they don't send it back, a payload, which will default to an empty object, and that's it. But now we actually want to add a third optional parameter to this function callback, which will allow anyone who is calling back as a handler to send a third variable to us, and that variable is going to be content type. Now, since no existing handler is calling this back, they're only ever calling back status code or payload, we are going to have to create a sensible default for content type that won't change the behavior of any of the existing routes or handlers. For our case, we're going to make sure that the content type, if it's not specified, defaults to JSON. So here we want to determine the type of response fallback to JSON. So we want to say that the content type should equal a string, and if it does, use whatever it is. Otherwise, default to a string called JSON. Up until now, in all cases, we have simply sent back the content type header as always set to application/JSON, and we have written the payload string to the body, defaulting it to an empty JSON object. Now we need to refactor this section a bit to check if the content type being served should be JSON, in which case this behavior should stay the same, or if the content type is going to be HTML, in which case a different header should be sent out, and rather than defaulting to an empty object, it should default to an empty string. So rather than simply saying we want to return the response, we say that we want to return the response parts that are content specific. And then we want to return the response parts that are common to all content types. Let's start with what are common. Writing the status code is going to be common to all requests. And writing something that is defined as payload string is going to be common to all requests. It's just that what that payload string is will vary depending on the content type. So first, we need to default the payload string to an empty string. Then we want to say if the content type equals JSON, we want to do certain behavior. Otherwise, if the content type equals HTML, we want to perform other set of behaviors. The behavior that we want to do if the content type is JSON is much of this behavior that exists up here. We want to set the headers to content type application JSON. We want to default the payload to an empty object. And then we want to override this payload string variable with the JSON stringified payload. Alternatively, if the content type is HTML, I'm just going to copy this header from here. We want to say that content type, instead of equals application slash JSON, that's going to equal text slash HTML. Secondly, we want to say that the payload string is going to be set to type of payload equals string, payload, or empty string. In other words, if the existing payload that's being called back by the handler is already a string, then that's the string we need to use. Otherwise, we're going to use an empty string of our own. For these HTML handlers, calling back an object is not going to work. We're expecting these handlers to call back strings so that we can write them to the body of an HTML document. Now that we have this set up, I'd like to create a simple hello world route on the index handler that we defined in the router down here. So let's open up our handlers file. And we want to first note that everything below this point is going to be considered JSON API handlers. And we're going to create a section up here that is just going to be dedicated to the new HTML handlers that we're creating. The first handler is going to be the index handler, and it's going to be set up initially just like the JSON API handlers. We're going to say that handlers.index is going to equal a function, takes in data, and a callback. And initially, let's just make it callback nothing at all. This will make the status code default to 200 and the body default to an empty HTML string. But this is also going to make it default to JSON, so we actually want to make sure that the third parameter says HTML. So rather than having nothing at all, we're going to say undefined, undefined, and then HTML. Now let's start the app up and then view the index page in a web browser so we can see that this page is rendered. Okay, now I'm going to open up Chrome and try to view this page. Okay, now we can actually see that this page is at localhost 3000, which is the index of this site. I'm going to refresh it, and now I'm actually switching to view source, which you can see here. You can see that there is nothing coming out. I'm going to open up the inspector and then reload this so that we can actually just make sure that anything is happening at all. As we can see, localhost 3000 was fetched with a get, and the response headers were pretty minimal. We said content type text/HTML, the date, the transfer encoding, and keep alive, which is stuff that Node put on automatically. So far, so good. We're able to serve an empty HTML file to the browser. To make this a little bit easier, let's view it in Postman as well. I'm going to make a GET request to localhost 3000, and we see that we got back nothing at all, except a 200 and content type text HTML, as well as those other headers that I mentioned a moment ago. To debug this front-end application, we'll use a combination of the browser when it's useful and Postman when we need to do simple things that don't require actually rendering the HTML objects or viewing the CSS or anything like that. Now, let's go back and modify this new route so that it can serve some real HTML, such as a hello world message. I'll get rid of this. As you can see, I've added this comment that we want to reject any request that isn't a GET. So we want to say that if the data.method equals GET, we'll continue. Otherwise, we want to call back 405 undefined and an HTML string. Simply saying 405, that method is not allowed, but we're going to tell you that by serving an HTML content type and the 405 status code. If the data method is get, then we want to read in the index template, which we haven't created yet, as a string. And though this function doesn't exist yet, I'm just going to use it in anticipation. We want to call helpers.getTemplate and then pass it the word index because we want the index template. And we want it to give us back an error and a string. And that string should contain the actual template data. So if there is no error and there is a string, we want to continue and simply call back 200 and then the content of that template, and then note that this is HTML that we're calling back. So as you can anticipate, the template is going to hold a bunch of HTML, and our handlers will simply fetch those templates from the file system and then serve them with an HTML content type. If there was an error or there wasn't any template string, we want to call back 500 because something is wrong with the app. Now that we've set that up, obviously we need to go define this helpers.getTemplate function. So let's open up the helpers, and the first thing that we're going to need to do in this helpers file is add some dependencies, because in anticipation of what's coming, we know that we're going to need the path module. So we're going to require path, and we're going to need the file system. So we're going to require fs. Now that's right, that getTemplate function that we just referenced a moment ago. So down at the bottom, I'm going to create this new function that should get the string content of a template, and it will be called helpers.getTemplate. As we saw a moment ago, it's going to accept in a template name and a callback. The first thing that it's going to need to do is sanity check the template name. So we will set the template name equals type of template name equals string, and template name length is greater than 0, then whatever template name is defined as, or false. Then we only want to continue if template name is a good variable. Otherwise, we're not going to try to read a file of that name. So we will call back a valid template name was not specified. But if a valid string came through, then we want to read in the template file. So the first thing we're going to do is define a templates directory as path.join. This should look familiar from the data folder __ directory name, and then / templates /. So as you can see, we now need a new directory to exist in the root folder. We need to create a directory, so I'm going to do make directory templates, and there it is. Now that we've referenced that templates directory, we can try to use fs.readFile to pull in whatever the user is asking for. So we're going to say read file templates directory plus template name plus .html, because all these templates are going to be named something .html. Then we're going to read it in as UTF-8 and expect back an error or a string. As you can guess, if there's not an error and there is a string, and the string has a length of greater than 0, then we're just going to call back no error and a string to the requester. Otherwise, we're going to call back no template could be found. So now we have the basic scaffolding set up to read in an HTML template and then pass it back to a caller so that they can render it to the browser. But we don't have any templates yet. So let's go ahead and create this index template so that it can be rendered when someone requests the base directory. So within the templates folder, I'm going to create a new file called index.html. I'm going to open that up, and it's going to be a very simple HTML document. It's going to have an HTML opening and closing tag. It's going to have a head, opening and closing tag, as well as one for the body. And in the head, there's just going to be a title tag saying hello world. And similarly in the body, an H1 saying hello world exclamation point. Now that we've set that up, we've created this template that's living in the templates folder. When the handler gets called, we're going to use this getTemplate function defined here in order to read in the content of this template and serve it back to the browser. So when we go to Postman now, we start up the app and make this request to the base directory again, we'll see that a body is returned, and it is an HTML document. Similarly, when we refresh the page in the browser, we can see hello world. When I view source, we see the same HTML document that we created in the template folder. So that's our little hello world proof of concept of rendering HTML for the browser. Our API should still be working as normal. It's just that the paths have been moved up to live inside of another directory called /API. And now our app is ready to get a bit more complicated. So in the following lectures, we are going to add on some more features that let us serve more complicated content such as photos and CSS files. And then we are just going to start building out these HTML templates and the client-side JavaScript and CSS that will need to exist for our users to have a fully functional web app. But this basic concept of serving HTML to the browser has been accomplished here. So now we can kill the app and move on to the next lecture.